Hi guys, good evening. Hi. I hope I'm audible to everyone. So a very good evening from my side, and this is an extended session of our DSA, or you can say Master Data Structure Algorithm class with C++. Okay, so I welcome everyone to this session again. Those who have joined, and yeah. So basically, we here have gathered today just to cover up this is an extended session. You can say it is an extra session kind of thing. Here we'll be discussing the problem which we had discussed in the previous session using greedy algorithm, but today we would solve it with the dynamic programming. Okay, but before that I'll just do a small interaction with you all. Hi Gaurav, hi Ranu, good evening. Pradeep, Satya, great. Pradeep, Mobin, Prachi, Ranu again. Yeah, hi Savage, hi Ankush, how Anindita, Archit. Yep. Hi everyone. Good evening. Good evening. You don't have to put attendance today, Archit. Okay, how about that if I say, because this is just an extra session and you don't need to put attendance really. So what is so this session is basically I kept it because you guys told me you are excited, you are interested to learn the dynamic programming, how to solve that particular problem using dynamic programming. That is why I scheduled it. It was not in the planned curriculum, planned course. So you don't have to put curriculum, you don't have to put attendance really here. If you have not put attendance for the previous days, then you can put it. Yeah, hi Yogeshwar, hi Always on Demand, hi Rohit, hi Akash, hi, good evening everyone. But I would surely like to put here the some like assignment submission form link where you would submit all the assignment. Like many people ask about this, so I'll just pin this uh, assignment submission form link so that you can at least keep a note of it, or maybe copy and paste somewhere and keep it with you, and you would submit here. Anyway, you don't have to keep it. Everything is in the video description. You can any point of time you can come to the same video and check the description. You'll find every link, guys. Okay. Yeah, Anantapalli, hi. Sandeep, hi. Vpedia, hi. Akash, hi. Rohit, hi. Good evening. Good evening. So once again, welcome everyone to this. Yeah, good evening, Dipanshu, Subham. Yep. You don't have to put really attendance today. It is just an extra session. Okay. Yesterday assignment I had posted it. Savage, you can check the community. I had posted it, the assignment as well as the material in the same post. I have posted. Okay. Last date of assignment submission, right? Yes, 10th August, 11:59 p.m. You should be submitting it. Okay, before that. That is the deadline for your assignment submission. And yeah, guys, do not miss out, do not miss tomorrow's session. Tomorrow is your career and placement session. That is again a part of the same course. I would like you all to also attend a session, okay, where you would be guided upon how exactly to prepare and what all things might come up while you go for actual interview or a placement or drive or something. Good evening, Shubham. Yeah. So, what we were discussing in the previous class, we were discussing this minimum coin change problem, and we solved that using greedy algorithm. But again, we also came up to a situation where greedy algorithm did not work and did not give a solution. I hope you remember all I had said. Yeah, greedy algorithm is also used to solve optimization kind of problem, this minimize, maximize kind of thing. But again, not always it would guarantee that like it would give the actual solution. Let me also reiterate the same thing. Let me reiterate the same example so that you would just um, relate this class to previous class, and so that our learning would be smooth. Cannot see yesterday assignment anywhere. Savage, have you checked the pinned post of community? Please check it. I Let me also give you the community link here itself in the chat. Let me put, just give me a moment, guys. I'll put it here. Yeah, this is the community link. It is in the video description. I'm also fetching from the same place. Okay, or let me okay, this is the community link. Let me show you. I'll share a screen, guys, and let me show you where you can find that. Okay, right. I hope everyone is able to see my screen. Yeah. So I'm pasting the same community group link here. So let me hit enter. So I have already joined the group. Okay, so that is why it is showing me leave group because I have already joined, and these are you all who have joined. I can see Dakshita, Rahul, Kushi, Nama, Riya, and all. Okay, I see like there are more members also. I can click on show all members. Fine, that is fine. But we need to check the, yeah, this is the thing I had posted, guys. See, this was the assignment, and this is the link to the respective material for the linked list code and greedy algorithm code which we did in the previous class. I think now I hope you can now find it, assignment and material both. This material actually covers all the, like, whatever you have discussed till this point, all the materials are given there, okay, in the same post. So you don't have to search for day one material, day two material, day three material. It's the same, like it is there. Everything is there in the same post. Only thing is day one assignment has not been included there. I think you already have received the day one assignment earlier. Okay. Is it now like Chavez? Okay, got it. Okay, fine then. Yeah, Kruti, good evening, very good evening. Let's actually get it get down to our discussion, point of discussion. That is, uh, we were discussing how greedy fails on that coin change problem, minimum coin change problem. So we had taken this example. Let's say the amount we need to withdraw was today my this writing pad is working fine. I want to withdraw 11 rupees, let's say, and the available denominations are 5 rupee coin, 4 rupee coin, 3 rupee coin, and 1 rupee coin. This was the given. Okay. And here we said that greedy algorithm would fail because greedy already always chooses the best next element or next best element. For the time being, 5 would be treated as the best element. So it would pick up. Okay, so it would pick up one coin of 5 rupee coin. So left out amount, so 11 minus 5. Okay, I think I did a mistake here. We did not take 11. We actually took 7, if I remember it correct. Not 11, but 7, guys. Let's take the same example, whatever we discussed yesterday. I don't want anyone to lose a track of. So yeah, here even here 7 minus 5 is 2. So we have already taken 5 rupee we have made by taking one 5 rupee coin. 2 more rupee we had to make. And how is that? I cannot take 4 rupee coin. I cannot take 3 rupee coin. So only option left out is 2 1 rupee coin. 2 1 rupee coin. So total there would be 3 coins as per greedy algorithm. I hope everyone is following me. As per greedy algorithm, it would give you answer as 3 coins, but it is quite evident here by looking at it. You can say, wait a minute, why should I take one 5 rupee coin and two 1 rupee coin? I can just take one 4 rupee coin and one 3 rupee coin, and that makes 7 rupees, and that is actually 2 coin, not 3 coins. So answer here should be 2 coin, and that is 4 rupee coin and 3 rupee coin. But as per greedy algorithm, as greedy algorithm is always greedy about the next best element, always greedy about the shortcut, in short, like simply when say, so that would give you here a wrong answer. Okay, so the it was trying to minimize the number of coin, but eventually, as per its logic, as per its algorithm working, it is actually giving you more number of coins and not the minimum number of coins. That is what we discussed. Okay, I hope at least the base is ready. What is the problem with the greedy algorithm? We understood, everyone. I hope everyone is with me right now and understood what the problem where greedy algorithm is actually failing. And I had said this particular problem, this kind of problem here, actually can be solved with dynamic programming. Okay, so we'll see how dynamic programming solves this problem. But before that, I just need a confirmation here. Everyone understood the problem statement here. What actually the problem is with the greedy programming or greedy algorithm? What is the problem with greedy algorithm? Gaurav says yes. Okay, everyone here understood the problem statement and understood the problem with greedy algorithm in this particular situation. Right. Let's now talk about dynamic programming. My bad. Sorry, dynamic programming. Let's first discuss it in brief. What exactly is dynamic programming? Then we'll apply it here. Okay, fine. So what is dynamic programming? What is dynamic programming? So dynamic programming. What exactly is dynamic programming? Dynamic programming works on something, a principle or not principle, or it uses something called as memoization. It is not memorization, guys. It is memoization. You can search this term actually. In short, I'll just say what we normally do in dynamic programming is, let's say a problem is very big. So we break down that problem into small sub problems, and we find solution for those small, tiny problems, and later we combine those solution to get the final solution for the entire big problem. Got it? What we do in dynamic programming, we divide the entire big problem into small sub problems, and we then try to find out solution for those tiny sub problems. And later we combine all those solutions, tiny like solutions to those tiny problems, okay, sub problems. We combine them to get the final result of the entire big problem. That is what we do in dynamic programming. Understood, guys? Is it clear? Okay, a big problem P is divided into small problems, small tiny problems. Okay, and then we find solution for this each tiny problem. Okay, let's say S1, let's say S2, and so on. And then we combine all these solutions to form the bigger solution for the entire big problem. Exactly, this is what we do in dynamic programming. So when I say actually here, a big problem is divided into sub problems here. Okay, so you can think it of like, I have a problem with, let's say, 5 element. So next time I may get, like, it might be splitted into problem with a 3 element and problem with 2 element. Okay, this problem with 3 element might be splitted into problem with 2 element and problem with 1 element. This might be splitted into problem with 1 element, problem with 1 element. This p2 might be split into problem with 1 element, problem with 1 element. Then I'll find solution for this, solution for this. I'll combine this thing, then I'll get solution for this. Okay, see now here same p1. For this p1, I'll not find again the solution. I'll not compute the solution again. Okay, I'll not compute the solution again, because already I have found solution for this p1. So that particular solution I'll reuse here. Okay, right? We'll use some kind of table. Okay, we'll store the result of the previously, like we'll store the previous results, the result of the small problem. Whenever we come across the same problem, we'll just reuse the solution again. We'll not compute it again. That's what this dynamic programming does. Okay, right? Vishal, you can check the community group. Just scroll down a bit and you will see, like, I have posted their assignment and what is that? Materials. Okay. Also, the day one assignment is updated on the top. The first pinned post, you can check there. First day post would be there. First day assignment would be there. Okay. Don't worry about it. Okay. Drasti says, okay, I hope I have pronounced it correct. So you want me to repeat? Yes, I'll repeat. See, what we do here is we take a big problem, we split up that big problem into small problems, and then we find solution for each of the small problem, and then we combine them together to form the big solution for the entire problem. Okay, that is what we do in dynamic programming. Okay, got it, guys? There is a big problem with us. We split up into small problems. We find solution to those small problems. We combine them and make the solution for the bigger problem, entire problem. Last date is 10th August. Okay, 11:59. So today you'll not have any assignment. Okay, this is just an extra session. I'm here just because you asked me to come for this session and cover this dynamic programming thing. That's it, nothing else. Okay, yeah. Then what is the next thing? First part we understood what we do, like what we do in dynamic programming. A big problem is splitted into small programs, small problems, and solution is found for each of those small problems, and those are combined finally, and the bigger solution is found for the entire problem. One more thing, like here, this is the I split it up. Like problem with 5 element was splitted up, problem with 3 element and problem with 2 element. This problem with 3 element got splitted up into problem with 2 element and problem with 1 element. Then this problem with 2 element got splitted into problem with 1 element, problem with 1 element. Similarly here, okay, P2 is actually splitted into P1 and P1. Got it? So I'll now here find solution for P1, guys. I'll now find here solution for P1, and here for the P1, you see P1 is again repeated. The same problem is repeated. So what I'll do is I won't compute the answer again. I'll just reuse the previously calculated solution, which would be stored in some kind of table. That is memoization. We'll reuse the previously calculated result. Will not redo it again. Okay. So when I say when a problem is divided into sub problems, okay, and those sub problems should be repetitive in nature, guys. Only then we can apply dynamic programming. Okay. In those cases, dynamic programming is applied. In short, maybe I can give you some better example that would make it very clear. Consider this Fibonacci of 4, Fibonacci series of 4. Okay, I think you all know this. What is the recursive call of Fibonacci 4? It would call Fibonacci of 3 plus fib of 2, right? Then this would call Fibonacci of 2 plus Fibonacci of 1, right? This would call fib of 1, and this would be Fibonacci of 0, right? And this would again call Fibonacci of 1 plus Fibonacci of 0, right? Okay, this is what we are doing here. So you see here, this Fibonacci 1, Fibonacci of 0, these are repetitive in nature. The same sub problems are repeated. This is a big problem which are divided into sub problems, and those sub problems are repetitive in nature, are repeated actually. This is where dynamic programming can be applied. Okay, first condition is the problem can be divided into sub problems, small sub problems, and those small problems should be repeated. Okay, so what happens here when the sub problems are repeated? If I get the solution for fib of 0, I'll store it somewhere in some memory, in some table. If I get here a result for fib of 1, I'll store it somewhere in the table. Next time when I get fib of 1, I'll not calculate the result again. I'll just use the previously calculated result. I'll just use it here. Similarly, here fib of 2 is calculated here. Next time here, see guys, what happens here? Next time when you go to this right side, you see again fib of 2. Instead of calling again this fib of 1 and fib of 0, you don't have to call it again actually. Already you have found the solution fib of 2, and that would have been stored in some table. That value you can actually reuse here directly. You don't have to calculate again. You don't have to call the sub function again or the recursive step. It would omit that recursive step. Okay, the biggest advantage of dynamic programming in such cases is this recursive solution for Fibonacci series time complexity would be 2 to the power n. Okay, but if you use dynamic programming, the same for the same problem, this can be solved in linear time complexity. That is the biggest advantage, guys. Okay, see how it is optimizing also the time complexity. Where is 2 to the power n time complexity? Where is big of n linear time complexity? It is reducing the time complexity to such an extent. It is actually reducing the repetitive recursive call. It is optimizing that, and still you are getting the result. I hope dynamic programming part is clear. So two conditions here where dynamic programming can be applied. One is problem can should be able to be subdivided into sub problems, and those sub problems, small sub problems, should be repeated. Should be repeated. There we apply this dynamic programming. What happens in dynamic programming is when we find solution for one small problem, okay, we save that result in some table. Later when we find the same sub problem, instead of calculating the result again, we use the previously like the stored result. We don't calculate it again, avoiding more calculations, avoiding the calculation or more function call. That's it. This is all about dynamic programming, guys. This is where dynamic programming is used, and this is where dynamic programming helps us. Is it clear, guys? I have not got into solving that problem, but I hope you understood what dynamic programming is and where it is actually applied and what exactly it does. Yes, is it clear? Please let me know in the comments. Is it clear or not? And then quickly I'll move on to the solving that problem. Okay. Okay, great. Uh, I'm yet to receive get some responses here. Is it clear? Did you understand, guys? Whatever I said. Okay, Prati says yes. Gaurav says yes. What about others? Like there are many people here. Did you understand this? Got it, Movin? Vishal? No, Vishal, you didn't get? Okay, so understood. Okay. Vishal could not understand. See, Vishal, I'm saying if you see this Fibonacci recursive definition, okay, the same sub problem are repeated. Once you have found solution for one sub problem, and if that repeats again next time, you'll just instead of calculating that again, you just use the previously calculated result. So you have to store whenever you find a solution, you store that in a tabular form or somewhere in the memory, so that later on when you find the same problem again, instead of calculating, you'll reuse the previously calculated result. That's what is dynamic programming is all about. Okay, now let's apply the same thing in our problem, that is this minimum coin change problem. I'll take the same problem which greedy could not solve, that was available denominations was like 5, 4, 3 and 1. These are available denomination. I'll write AD, and withdrawal amount was 7 rupee. Okay, so now let's see what I'll do. So there are actually two approaches. Vishal, I think, okay, you have to look, just check out, okay, after this session, just check out the recursive definition for, or the recursive function for Fibonacci series, then you'll get it, okay? The recursive definition for Fibonacci series is if fib of n, it would give you fib of n minus 1 plus fib of n minus 2. This is the recursive definition for Fibonacci series. You can check it out after this session. Then your doubt would be clarified. Why actually fib of 1 and 0, 1 plus fib of 0 and not fib of 1 plus fib of 1. Okay. Fine. So here we are again. So just follow the thing, guys, whatever I'm now going to say. In the so I'll be writing something called in tabular form. Okay, so in rows I'll write the available denomination like in increasing order. So 1, 3, 4 and 5, these are available denominations. Okay, remember this, these are available denomination I have written. So if I'm here in this row, I mean to say, okay, there are only 1 rupee coin available. So many of 1 rupee coin available, infinite number of 1 rupee coin available. Okay. If I go to this row, if I'm here, that means I have, if I'm here, I mean to say there are infinite number of 1 rupee coin. If I'm in this row, I mean to say I have both infinite number of 1 rupee coin and 3 rupee coin. This is very important, guys, understand. If I'm on this row, I would mean that I have 1 rupee coin, 3 rupee coin, also 4 rupee coin, and each coin would be infinite, like would be like available in abundance. There will be no shortage of that. Then secondly, here I mean that I have all the possibilities of the denominations. This is what you need to understand in dynamic programming when we maintain this row. Okay, first row means we just have 1 rupee coin, like 1 rupee coin, but infinite number of 1 rupee coin. When we go to second row, it means we have both 1 rupee coin and 3 rupee coin, infinite numbers of. Then third row, we have 1 rupee coin, 3 rupee coin, and 4 rupee coin. And we go to the last row, we mean that we have all these possible denominations of infinite numbers. What we would put in the column, that's again very important. One more row you can actually add, that is 0. You say, okay, 0 coin, 0, we normally add it for our convenience. You may not add it, it is not necessary that you need this 0, but yes, it's better when you are starting to you're starting to learn and starting to solve dynamic programming. It is better you have this 0th row, also 0th column. Okay, you write this 0 column and 0 row, that is better, right? Okay, so what I'll do here is I'll draw that table. I need that table. Table is important. Dynamic programming, majorly solving dynamic programming problems is mostly about drawing this table and putting the values here. Okay, filling those values. So okay, 0, 1, 2, 3, 4. I'll explain this, guys. What is this? Don't worry about it. So 0, 1. Okay. This is available denomination, and this is the withdrawal amount, guys. Withdrawal amount. Okay, I mean to say I'm writing all the possible withdrawal amount from 0 to 7. I need to withdraw 7 rupees. So in the column, I would write all possible withdrawal amount. What if? So it is a very generic solution. The dynamic programming solution is very generic solution, guys. So it is not about just to find how many coins, how many minimum number of coins is required to withdraw 7 rupees. No, it is not like that. When you find actually a minimum number of coin for 7 rupee to withdraw 7 rupee, in the process you would also find what would be the minimum number of coin to find 1 rupee. Okay, what would be the minimum number of coin to withdraw 1 rupee, what would be the minimum number of coin to withdraw 2 rupee, what would be the minimum number of coin to withdraw 3 rupee, what would be the minimum number of coin to withdraw 6 rupee. Finally, you would also find what would be the minimum number of coin to withdraw 7 rupee. So it's a generic solution. So we'll take all possible values of this withdrawal amount from 0 to with 0 is not required, but yes, for our sake of convenience, we'll take this 0. Understood, guys? Is this clear? The table. This is the very first thing and very basic thing. If you make mistake here, then obviously you would end up with a wrong solution. So the rows are available denominations, and I've already told how would you consider this when you move to the next row. What should you consider? What that means? Okay, right? And these columns represent the amount, withdrawal amount at that particular column. When I am, let's say I am here, I'm here. That I mean to say, okay, I want to withdraw 5 rupee. I want to withdraw 5 rupee. That's what. There would be no, yeah, there will be no assignment for today. Poonam, you can always put like you can check back the previous sessions. Okay, you can, like, those are very informative. Your friends over here in the comment section, they would like confirm the same. There's a very informative. You can check back, always check back those courses and put up the attendance. Okay, it is open right now. Later also it would be open till tomorrow actually. So you can check all those courses and put the attendance. Right. Okay. Tomorrow is one more session, career and placement session. After that, your attendance would be closed. Fine. Is everyone with me up to this point, guys? What is row? What is column? Clear, everyone? Yogeshwar says yes. Vishal says yes. Now I would start putting values, and this is the very crucial part which we need to focus on. This is the part where we are actually applying greedy algorithm, dynamic programming, And this is the whole concept here, which we discussed conceptually. We'll be applying it here. Now you would actually realize, yes, we are using the previously calculated solution here. Let's see here. Okay, let's see here. Okay, see. So when I have, when I'm here, zero column. So to withdraw 0 rupee, how many coins I can take of 0 rupee coin? So this is 0 rupee coin, right? How much coin I can withdraw? Obviously zero. Okay. Then these are also zero. To withdraw zero, I'm now in this row, let's say. Okay, to withdraw zero amount, how many coins of 1 rupee coin I can take? Zero coin. To withdraw 0 rupee, how many coins I can take of 3 rupee, 1 rupee, and 0 rupee? Kind of that way. Okay, zero. So all this column, entirely this column, the zeroth column would be zero, because to withdraw zero amount, I did not take out any coin. So that would be zero number of coin. Okay. Mark, please understand this. Whatever value I'm putting in the table, that denotes number of coin. Okay. So to make 0 rupee, I need zero coin. To make 0 rupee, I need zero coin, zero coin, zero coin. That is what I'm putting. Okay, right. Again, now here to make 1 rupee, how many 0 rupee coin I can take? Zero. I cannot take. Okay, zero. So these all would be also zero. To make 7 rupee, how many 0 rupee coin I can take? Zero. So this zeroth column and zeroth row, I put zero. Okay, right? No, Vishal, you cannot write, because available denomination is given to you. Only 5 rupee coin, 4 rupee coin, 3 rupee coin, and 1 rupee coin are given to you. So 0, 1, 2, 3, 4, 5, 6, that would give you wrong result, because then you are taking all possible denominations. This is not as per the question. Okay. Right. Now the exact thing starts. Like now the actual task, the real problem start. Now we would start putting the result. Okay. Now the zeroth row and zeroth column is all sorted. Now focus on the this column. Now I'm here in this column. That means I need 1 rupee. Okay, and I'm in the first column here. That means I have abundance of 1 rupee coin. To make 1 rupee, how many 1 rupee coin I would take? The answer is 1. I'd need only one rupee coin to make total 1 rupee. I want to withdraw 1 rupee. I have only 1 rupee coins. So many 1 rupee coins. How many coin I will need? One, just one. That is the answer here. Next, now in the next column. Now I am in this column where I need to make 2 rupee coin. I want to withdraw 2 rupee. Okay, for the same row, guys. I just have 1 rupee coin, so many 1 rupee coins. I want to make, or I want to withdraw 2 rupee total. How many coins I can take of 1 rupee? How many coins I can take of 1 rupee? I'm in the second column here, and I want to withdraw 2 rupee. I just have 1 rupee coins, so many 1 rupee coins. So how much, like what would be the number of coins I will take? 2 1 rupee coin. If I take 2 1 rupee coin, that would make 2 rupee in total. Okay, right? Similarly, when I'm here to make 3 rupee, or to withdraw 3 rupee, how many 1 rupee coin I need? The answer is very simple. Same thing. 3 1 rupee coin would make 3 rupees. Similarly, to make 4 rupee, I need 4 1 rupee coin. So 4. Okay, right? Similarly, to make 5 rupee, I need 5 1 rupee coins. So just put 5. Similarly, this would be 6 and this would be 7. Okay, I'm not copying the values written above. I'm just seeing how many coins I need of this 1 rupee coin to make the amount which is mentioned above. That's what I'm doing. Is this part clear, guys? This first row, I would say. Is this part clear? Why it is 1 2 3 4 5 6 7? Because I only have 1 rupee coins, abundance, infinite number of 1 rupee coin. So if I want to make 7 rupee, I can take 7 coins of 1 rupee. If I want 6, if I want to withdraw 6 rupee, then I would need 6 1 rupee coin. So that's why the answer, the value would be 6 there. Remember, whatever value I'm putting in the table, that is actually number of coins. Okay, that is not the amount or something. That is the number of coin, because I need the answer we are searching for is minimum number of coin. Okay. Now shift down to next row. For the first row, we have solved all the problem. We have actually put all the values. Now come to the second row, this row. Now I have 1 rupee coin and 3 rupee coin. Two kind of coin I have, and infinite number of 1 rupee coin and 3 rupee coin I have. Okay. Now here you are here. When you are looking at here, so let me erase this part. I want to go serially again. Okay. Now we are here again. So you need to put the value here, fill here value. You need 1 rupee total. You want to withdraw 1 rupee. You are here in this row. So can you take a 3 rupee coin? Okay. You are in the second row. So even here you will check, can you take 3 rupee coin? To make 1 rupee, I cannot take a 3 rupee coin. Okay. So in that case, in those case, what you will do, you will just copy the previous value, guys. What is the previous value? Previous value is 1. So you'll just copy 1 here. Just write 1. See, this is where we are applying dynamic memory. Sorry, my bad. Dynamic programming. Okay. We are using the previously calculated value. We are not calculating it again. We just checked. Okay. Can we take this coin? No. Then what is the result? Just go for the previous value. Copy it down. Use the previously calculated result. So to make 1 rupee, I have so many 1 rupee coin, I have so many 3 rupee coin. But the thing is, I cannot take 3 rupee here. I'll just go with the previous value, whatever calculated. That is nothing but 1 rupee coin. Now, come to the second column. Now you need 2 rupee. Can you take 3 rupee coin to make 2 rupee? Answer is again no, because obviously 2 is less than 3. So I cannot take 3 rupee coin. Again, you copy the previous value, that is 2. Okay, you will take 2 1 rupee coin that make 2 rupee. I hope you are following this. Now finally you are in this row. Now see, now this is the point where everything, like the things would get changed. Now you have to withdraw 3 rupee. Okay, you have 3 rupee coin and 1 rupee coin. Can you take a 3 rupee coin? Answer is now yes. To make 3 rupee coin, I can take a 3 rupee coin. Okay, just somewhere write it. Okay, somewhere you write it. The amount I need is 3. Okay, and somewhere you write also the coin count. Okay, if I take 1 2 rupee, 1 3 rupee coin, the amount will become 3 minus 3 equal to 0. Okay, right? What is the left out amount? What is the left out amount? Left out amount is 0. So I don't have to worry about much. I already have completed the amount. Whatever amount I had to withdraw. Available denomination, Drasti. Okay, sorry if I'm pronouncing it wrong. Okay, it is available denomination. So yeah. So I wanted 3 rupee. I have the option of taking 1 3 rupee coin. I'll take it. Okay, but you cannot actually see. We are human being. We are seeing it. Yes, so we'll put it 1. No, but when you program, when you code it, you will actually compare with the previous value. What is previous value? 3. What is new value? 1. Which is smaller? 1. So you'll put 1. So to make 3 rupee, if you have option of 1 rupee coin and 3 rupee coin, you just take 1 3 rupee coin. That is your answer. Okay, while coding it, you need to check your condition, check the condition here. What was the previous number of coin? 3. Now we are getting only 1 coin. What is minimum? 1. So I'll put minimum value 1. See, things are getting changed. You'll get hold of it. Just be with me for 1 to 2 or 3 more values. You will understand what I'm doing here. Now let's go to the next column. I need now, okay, I need here now 4 rupee. Okay, so 4 rupee is what I need to make. Fine, I'm here in this row. Can I take a 3 rupee coin? Answer is yes, I can take a 3 rupee coin. Okay, but if I take a 3 rupee coin, The remaining amount is 1. So I still need more coin. So the number of coin is 1 plus what is the more number of, like, what is the remaining number of coin, you need to check. How would we check? This is the point. See, please, in the previous case, the total amount became 0, so we don't have to think much. We didn't have to think much. But now the amount we need is not fulfilled yet. Okay. So what we will do, see guys, in the same row, okay, the remaining amount is 1, right? In the same row, just go to the column 1, see the value. What is the value? 1. So that is what you will put. 1 plus 1 is 2. Answer would be 2, yes, but before that you should check which one is minimum. Previous value is 4, new value is 2. Which one is minimum? 2. So your answer would be 2. Okay, right? So I'm actually basically doing here minimum of, let's say, this table, the entire table. This is consider that this is a 2D array. Okay, 2D array, maybe C array. This is 2D array. So I'm checking basically minimum of the previous value, C of I minus 1 j, previous row. Okay, like I'm trying to put your value, right? I will compare this value, the previous row value. That is why I have written here C of I minus 1, previous row. Okay, for the same column, previous row, what is the value? 4. And now we are calculating it. Okay, we are calculating the new value here, that is 1 plus C of, okay, in the same row, j minus this value. What is this value? You can say this is basically second. So if you consider it, if I have 1 3 4 and 5 in this way, if you write, okay, the array in increasing order, which we should be writing actually 1 3 4 5. So you can say here as j minus this ad of 1. Okay, right? This is what we need to do. This is what we need to do. We are checking for minimum, which is minimum between the previous row value. This might look very complicated. Just try to understand here, guys, what I am trying to say. You check the previous value, that is 4, and now we'll calculate here. Okay, so how would we calculate this? So you want to withdraw 4 rupee. Okay, you are at here in this row. Can I take 3 rupee coin? Yes, I can take 3 rupee coin. So one coin you have taken. How much more coin you need? Okay, that depends on the remaining amount you want. What is the remaining amount? So amount you needed 4. Now you have taken a 1 3 rupee coin. Remaining amount is 1. So in the same row, if you go to this column 1, you will find the value, the remaining number of coin. That is what you need to add, and it would come out to be 2. So 2 and previous value is 4. Whatever minimum, whichever is minimum, you use that. So here 2 is minimum. So you'll write 2 here. Am I making sense to you guys? Are you understanding whatever I'm doing? The same thing I'll repeat. So if even if you are not following, or even if there's a bit little doubt in this, please be there with me. I'm putting here other values. It would really make sense. Just be there. I'm doing the same thing. I'll be doing the same exact process. Okay, so now see this. I want to withdraw 5 rupee. Can I take a 3 rupee coin? Yes, the answer is yes. Okay, so let me erase this part. And coding dynamic programming question is nothing difficult, guys. It is you just have to work with 2D array. If you know how 2D arrays are managed and how to access value in 2D array, then you are good with dynamic programming solutions. Okay, yeah. So I need now 5 rupee. I can take a 3 rupee coin. Okay, I can take a 3 rupee coin. So if I take a 3 rupee coin, so okay, one coin I am taking of 3 rupee. Remaining amount is 2 rupee. So how much more coin I need? Same thing, just in the same row, go to this column number 2. 2 more rupee I need, right? In the 2 column, what is the value? 2. So that is what is the answer. You need 3 total coin, which is minimum 3 or 5. Previous value is 5. Now you got 3 coin. 3 is minimum. Put that answer. Okay, 3 coins. Next, you are here in the column 6. You need now 6 rupee. 6 rupee you need. Okay, 6 rupee. Can I take a 3 rupee coin? Yes, I can take a 3 rupee coin. So one coin I'm taking of 3 rupee. How many more coin I need? Like, how many more coin I need? The remaining amount I need to make 3 rupee. Just go to the, in the same row, go to the column 3. What is the answer? 1. So 1 plus 1, that is 2. 2 coins. 6 is more than 2. So I'll go with the minimum 2. Basically, it is quite obvious. 2 3 rupee coin will make 6 rupee. That's what. Okay. No need of putting attendance Vaishnavi today. Okay. It is just an extra session. If you have not put attendance for the previous sessions, you can check back the other sessions and all. You can fetch the attendance form from the description. Yeah, now we are at the last row or last column. 7 rupee is what I need to withdraw. Okay. Can I take, the question is, can I take 3 rupee? Yes, I can take 3 rupee. So number of coin I'm taking is 1. That is a 3 rupee coin. How much more amount I need? 4 rupee. Obviously, I'll need more coin. What is the number of coin? To find that, in the same row, go to this column, 4 column. Okay. What is the value here? 2. So 1 plus 2. Total 3 coins you need to make 7. Okay. Total 3 coins you need to make 7. I'll just use the same color here. Okay, it's quite obvious, like 2 3 rupee coin and 1 rupee coin, that would make 7 rupees. Okay, so second row also we have completed. It's time we go to this row. Okay, so now I have like 1 rupee coin, 3 rupee coin and 4 rupee coin. So again you come to this, let me erase that, this arrows, because again we will start from the beginning. Here I need 1 rupee. Can I take a 4 rupee coin? I cannot take, so just copy the previous value, 1. Now I need 2 rupee. Can I take a 4 rupee coin? No, I cannot. Just copy the previous value. I want 3 rupee. Can I take 4 rupee coin? No, I cannot take. Just copy the previous value. I need 4 rupee. Can I take 4 rupee coin? Yes, I can take 4 rupee coin. Okay. So now this is where things would get changed. So I need 4 rupee coin. I'm taking 4 rupee coin. So remaining amount is 0. Okay. Right? So what is the remaining coin you need? In the same row, check the 0 column. What is the value? 0. So 1 plus 0, that is 1. Whichever is minimum. Previous value is 2 and you got now 1. So 1 is minimum. So you need actually 1 coin to make 4 rupee coin. Okay. Now you are here. Okay, as you go on guys, your amount, the task you are doing getting reduced, because previously you have already calculated those values. You are actually reusing instead of calculating it again. You're just reusing it. Okay, so now you want to make 5 rupee. 5 rupee you want to make. Okay, fine. Just a moment, I think I need to zoom out. Yeah, so here I need to make 5 rupee. To make 5 rupee, can I take 4 rupee coin? Yes, I can take. So 5 minus 4, remaining is 1. I've taken 1 rupee, like 1 coin of 4 rupee. The remaining amount is 1. So what I will do, in the same row, in the column 1, I'll check what is the value, 1. So 1 more coin I need, that is 2. Which one is minimum? Current amount or previous amount? Previous amount is 3. Now we have found 2. So 2 is the answer. Minimum, whichever is minimum, that you will put. Next, 6 rupee you have to withdraw. 6 rupee. Can I take a 4 rupee coin? Yes, I can take 4 rupee coin. So total coin I am taking is 1. 1 coin I am taking, value is 4 rupee. So I need 2 more rupee. Okay, so what is the remaining number of coin? Same thing, same in the same row, go to this column 2. What is the value? 2. So 1 plus 2, that is 3. But what is the previous value guys? Previous value is 2. Now we are getting 3. What is minimum? Minimum is 2. So you'll put 2. Okay, you'll go with the previous combination, 2 coins to make 6 rupee and not 3 coin. You'll not take the current result, because current result is giving more. You'll go with the previous, whichever is minimum between the two. you'll take that. Now finally we are here. We need to make 7 rupee coin. We want 7 rupee. So can I take a 4 rupee coin? Yes, I can definitely take one 4 rupee coin. 7 minus 4, remaining amount is 3. So what is the remaining number of coin? In the same row, check out the column 3. The value is 1. So 1 plus 1, that is 2. Previous value is 3. Now we got 2. So answer is 2. So 2 coin, only 2 coin is required to make 7 rupee by using 1 rupee coin, 3 rupee coin and 4 rupee coin. Okay, right? Now next, again we are at the last row. So we are almost like at the end of this problem. So to find a solution of this problem, same thing guys. Again we would repeat the same process here. We would be starting from 1 rupee the amount. Yeah, so I need 1 rupee. Can I take 5 rupee? No. Copy the previous value. I need 2 rupee. Can I take a 5 rupee coin? No. Just copy the previous value. I need 3 rupee. Can I take 5 rupee? No. Just copy the previous value. I need 4 rupee. Can I take a 5 rupee coin? No, not yet. Wait, I cannot take. Just copy the previous value. Now I need 5 rupee. Things will now change. Yeah, I can take now 5 rupee coin. That's what. Okay. I can take. Oh, my bad. Just a moment, guys. Just a moment. I think I have erased from here. Okay. Yeah, fine. So I would. Okay. I think my system is lagging a bit right now. I'll erase this stuff and I'll explain. Okay. I think I have some spaces here. I can use that or something. I don't know what exactly happening here. My is the problem is of writing pad or my system? Fine. Anyway, I think now we can live with this. I can write it here. Okay, now I need 5 rupee. I can take a 5 rupee coin. So 5 minus 5. I have taken a 1 5 rupee coin. 5 minus 5 is 0. So what is the remaining number of coin? The same thing in the same row, go to this 0th column and the value is 0. So 1 plus 0 is 1. What is the previous value? 2. What we have got now? 1. So answer is 1. Okay, whichever is minimum. You can actually solve it along with me. That would actually make it more clear. Now we need 6 rupee. I need to withdraw 6 rupee, guys. And can I take a 5 rupee coin? Definitely yes, I can take a 5 rupee coin. So I'm taking a 5 rupee coin, one coin of 5 rupee. So the remaining amount is 1 more rupee. So how can I find the remaining number of coin? Easy. In the same row, go to the row one, sorry, column one, and you'll find the value that is 1 here. So 1 plus 1, that is 2. What is minimum? Previous value is also 2, say now is also 2. We are getting the same value. So 2. Okay. Now finally the last field, and that is our answer, guys. Whatever value we'll get in this cell, that is our final answer. Okay. So we need here 7 rupee. Can I take a 5 rupee coin? Yes, I can definitely take a 5 rupee coin. So 7 minus 5, remaining amount is 2 rupee. So how many more coin I need? Same thing. In the same row, go to this column 2, find out. It is 2. So 1 plus 2, we are getting 3. What is minimum? Previous value is 2. Now we are getting 3. Minimum is 2. This particular thing is your answer. You need 2 coins, guys, to withdraw 7 rupee. Minimum number of coin to withdraw 7 rupee given this available denomination is 2. Okay, you just have to print the last value of this 2D array, this table. That is your answer for this problem. And here we have followed something called bottom to top approach. Okay, we have solved the smaller problems and we then filled the bigger problem using those smaller problems. Is it clear? Did you understand, guys, why, like how exactly we apply dynamic programming and how we got the result here? Did you understand, everyone? This is exactly, this is dynamic programming. So everyone gets scared about dynamic programming, but this is like so easy actually. This table, you just draw a table and just figure out, okay, this is we have found out this already. So next time I can use this value. Okay, everyone, is it clear? Answer is 2, and yes, 4 rupee coin, 3 rupee coin. That is our answer. Okay, so guys, it is not an assignment, but I would really like or also it would be very helpful for all of you. You have attended the session, you understood how it is working. If you try to code it out, okay, by yourself, understood the process, just try to convert that problem solving process into a code just by taking this 2D array. Take this table as a 2D array where you have rows and column. Row, you consider this the available denomination. Column, you consider that it is the amount we want to withdraw, and try to implement this. Surely, like you would if I've understood properly the process, then you can easily actually implement the, you can write the code for that. Okay, if you face problem, come again to this video, see the process how it is solved. But before that, you try to solve it once or twice by yourself. Okay, I can give you some also some more problem also. Is again a classic problem. It is rod cutting problem. I don't exactly remember the values. I can give some dummy values. Okay, rod cutting problem. It is again a very classic problem. Okay, some rod of like let's say 1 meter, 2 meter, 4 meter, 5 meter, maybe. Okay, maybe 7 meter. Rods of pieces of rod, each of 1 meter length, 2 meter length, 4 meter length, 5 meter length, 7 meter length. Maybe it is given. Okay, or maybe you should go for actually this way, not this. I would actually basically I'll do this. So rods of 1 meter, 2 meter, 3 meter, and 4 meter is given to you. Let's say it is said that these rods of this length are available. 1 meter rods are available, 2 meter rods are available, 3 meter rods are available, 4 meter rods are available. And the question is given to you. You need to sell total 5 meter of rod. Okay, and you should have maximum profit. Okay, profit value of each rod would be given to you. For example, let's say if you sell 1 meter rod, then you'll get 2 rupee profit. If you sell 2 meter rod, you'll get 4 rupee profit. Let's say if you sell maybe 3 rupee profit. If you sell 3 meter rod, you'll get 5 rupee profit. And if you sell 4 meter rod, 4 meter rod, if you sell, then you'll get, let's say, 8 rupee profit. So in order to sell total 5 meter of rod, total length 5 meter rod you want to sell, what how would you choose this rod, or what would be the maximum profit you can make actually? Okay, in short, like you can say to make 5 meter total, I can take 1 2 meter rod, 3 meter rod. Okay, what is the profit I'll get? 5 plus 3, 8 rupee I'll get profit. Okay, if I take 5 1 meter rod, 2 rupee, 2 rupee, 2 rupee, 2 rupee, 10 rupee I'm getting. So which is more? Actually, the profit is more if I sell 5 1 meter rod and not 1 2 meter rod, 3 meter rod. Okay, but again, if I take 1 4 meter rod and 1 1 meter rod, the profit I'm getting is 8 plus 2, that is again 10. So I can also sell 1 4 meter rod and 1 1 meter rod. So this is the problem statement. You can also apply dynamic programming here in this rod cutting problem also to get the answer. Okay. Yeah, Vishal, like this is a 2D array program. That's it. Nothing else. You take the available denomination as a 1D array. Okay, maybe you can sort it in ascending order and keep it, and then you assume, you take a 2D array and you assume that zeroth row, zeroth column are dummy, like 0 0 0 0 would be there. Okay, because you will need it while coding. Like here, see, 5 minus 5 is 0. Okay, what is the remaining number of coin you need? So in the same row, you'll come to this row, zeroth column, right, for this value. So that is where you need this zero column and zero row. That is why I added it actually. Okay, consider that, okay, zeroth row, then one row is actually this one coin, 1 rupee coin. Two row, the row 2 is actually this zero row, one row, and first row, second row. Okay, not second row, basically row 0, row 1 is 1 rupee, row 2 is 3 rupee, row 4 is 4 rupee, and row 5 is 5 rupee. Okay, I think I have done some mistake. Row 0 is 0 rupee, row 1 is 1 rupee, row 2 is 3 rupee, row 3 is 4 rupee, and row 4 is 5 rupee coin. Okay, you can consider that way. Okay, right? Fine. And this column, you just think that, okay, this is 0, 1, 2, 3, 4, 5, 6, 7. That's it. Nothing else. Okay. You can also keep this 1, 2, 3, 4, 5 in another array. 1, 2, 3, 4, 5, 6, 7. Okay, you can keep it. The denominations, you can say 1, 2, or sorry, the amount, possible amount. Okay. So that J of, see, this C array, the 2D array, right? This will this would be corresponding to this amount array, this J value, it is J, right? So this would be A of J value. Okay, and this row would be corresponding to this AD array, AD of I. Okay, so C of AD of I, let's say I is 2. What is AD of 2? 3. So C of I is, that means you are in this row, 3 rupee. Similarly, let's say J is 2. J is 2. Okay. So if or J, let's say J is 4. What J is 4. So what is A of J, guys? A of J is 0, 1, 2, 3, 4. This 5. Okay. So C of IJ, C of 2, 4. C of 2, 4. That means it is AD of 2 and this is A of 4. What is AD of 2? AD of 2 is 0, 1. Okay. Where I have written? Yeah, 0, 1. Actually, I should have written this ascending order. 0, 1, 2, 4. Right? Okay. Then A of 4. What is A of 4? A of 4 is 0, 1, 2, 3, 4, 5. C of 4, 5. Kind of that way you can think it of. Okay, the value actually. It's like if you have understood the process, you can easily implement it. Just try it out, guys. Try it out. Or else what I'll do is you do it by your own. I would upload the material for this session for the code to this. Okay, I'll help you out. But don't look at the code first. You solve it by your own. If not possible, if you cannot solve that, then you look at the code. Okay, agree, everyone? I'll submit. I'll upload. I'll take some time. I'll need to. I would need, like, I'll be required to find some time to code it out, and I will upload it in the community for this particular problem. You try it by your own. Try to code it. It would be better if you like code it. Try to code it just after this session. If you don't if you don't, if you are not able to find, like, code it out, you can always look back to the community material. I'll post it soon. Not right now. I'll need some time to code it out, and you can fetch it. Maybe tomorrow we can fetch it. Okay, fine, guys. I hope that that is fine to all, like, with all of you. So is it clear the process, the approach, this problem solving? Okay, because in interviews also, if you go to, like, in product based company or something, they would give you a problem and they will ask you what is the minimum number of coin or what is the maximum profit with that rod problem. So you need to, on the paper, you need to draw this table and solve this thing and give that interviewer an answer. Okay, three coins or three rod or something. This is the maximum profit or something. Okay, great then, guys. So this is up. This is it. Like, this is all what I have planned for this session. Nothing more. We'll just wrap this up and we'll end this session right now. I'll upload the material in the form of, like, actually code to this problem. But also, I would like you all to try it by your own. If you like, I'd be delighted if you don't look at the community for this code for this material. But yes, if you are for your reference, I'll also add it so that you can always, like, get back to that code if you are not able to solve it. Okay, so that's it guys for this session. This was an extra session, and yep, thank you all. Even if it was an extra session, you all actually came and joined. And but I hope like I did not waste your time, and it was a fruitful session. Okay, you too only, Savage. You too. But tomorrow it is a career and placement session, not DSS session. But that is actually included in this batch, in this course only. That's it. Yeah. Also, one more thing, you can all reach out to me. You can like search me on LinkedIn if you have any query regarding any of this part, or else see directly. You can also put in the community. Just tag me in the. And I'm in the community, guys. If you have any, it would be better actually. I'm in the community. Tag me there. Put a question, and I'll answer you if you have any queries. Okay. Great. So yeah, that's it for today, guys. This is what we have planned. So yeah, so let's meet some other day, some other course. Yeah, tomorrow I'm starting with a Java programming batch. That is again a 3 day batch actually. Java programming. We'll start with the basics of Java and basics of OOPS. Okay, like 9th, 10th, and 11th of August. These 3 days I'll be there for Java programming. If you wish to join there, you can also join there. I think in the description of this video you would also find the link to that. So I think so, like it may not be there, but in the assignment sorry, in the attendance link I think it is there. I'll just put also in the chat. Just give me a moment. Yeah. Okay, so I'm also giving you I think here it has not been added yet. Just a moment, I'll give you all for that link for the Java programming. If any one of you are interested, it's not like I'm asking you all to join in, but if let's say anyone need help in starting with Java, or to need to understand the basics of OOPS, they can join that session and really get help out of it. Okay, this is the Java registration link, guys. You can use it. No, Prachi, no. Actually, it was supposed to be end yesterday only. This was the extra session I had taken, and tomorrow it is career and placement session. It was a 3 day session actually, just to give insight and basic idea to get all of you started with the DSA. Okay, so that you can by yourself dive more into the course and all. Okay, you can always check out our PGP courses, guys. We don't have DSA courses, but we have other courses like data science, machine learning, AIML, DSA, and like not DSA, AIML, data science. We have this web development, full stack web development. We have Python and Django. These are PGP courses. Okay, those are postgraduate programs. It's not like you need to be a graduate in order to attend those courses. You will be getting a post graduation level certificate, guys. Okay, do check out them. In those courses, actually, this DSA is like it is there, it is added to your courses as a bonus. DSA is there, system design is there, added to AWS are there. You would be undergoing some placement preparation. Also, some companies would also come to recruit you. You would be going through screening round by ourselves. We will prepare you for the like recruitment and placement and all. And that's how our PGP courses are actually running on. You can always check out the links provided in the video description below, and then you can decide. Ananta, yes, I'm from Odisha. Right now, I'm in Bhubaneswar right now, and from there, I'm actually teaching you all. Okay, so yep. Okay, LinkedIn profile link. You can always search, or I think it's. I'm not very sure. If I remember, I don't. If I remember it or not. But as far as I remember, it should be link.in slash. I'm not very sure. You can check it. Let me first check it and then put it here. Otherwise, it will show you a 404 error. There is no assignment Kuber for today. It was just an extra session. You all request, like you all just said you need to, you want this dynamic programming sessions. I just came here for that. I was supposed to be enjoying my weekend today, but yes, for you, I'm always, even this is enjoyment for me, not an issue. I think, yeah, this is the link. So I'm putting it here. Yeah, this is the LinkedIn profile link. Savis, which programming is best for future side job? I think like nowadays Python is gaining a lot of popularity, and if you are looking forward for data science, machine learning, and all, then I think it's better if you go for program Python and all. But also in the same time, if you are see any you go for any programming language, you need to be very good with that programming language. It's not like if you know C, if you don't know Python, you are bad. No, it's not like that. Whatever programming language you know, you should be good at that, at least one programming language. It is always better to know Python and all if you are targeting for yeah, if you're targeting for data science machine learning thing, then obviously you should go for the Python and all, because right now this is very growing. But also competitive coding, if you focus on and all, right now if you have if you're a graduate student and you are looking for companies, if you're like trying to get into companies, go through the recruitment round and all, okay, and their coding round are their competitive coding kind level, you can always go for C++. Okay, C++ you can fetch it. Okay, you can use it. Even you can go for Python. I'm not saying with Python you cannot do that, but yeah, the sole reason we are going for Python is its libraries. We don't have to write our own code, and we use its libraries. But actually in the competitive coding and all, they don't allow you to use those libraries and allow you the built-in functions. You have to write the logic again by yourself. Okay, so then why we would go for Python and all? Okay, so why we will not go C++? Just remember this: there's a difference in the execution time with this programming language. C takes the list, then C++, then Java, then Python. Okay, but again, depending on the language, right now they are actually increase the time limit. Okay, they have increased the time limit actually. So you want to go software engineering in future? Java is I think right now you can go with Java also. Okay, Java is also like good. Like Java, I see right now so many openings on Java. So many of my friends went like get into this, switched and get into this Java domain. Okay, not when I say Java domain, it's not about only core Java, like advanced Java, Hibernate, Spring, the J2EE part and all. But focus on basics first. Then you would anyway would learn in course of time. When you get into a company, anyway you would learn by doing things. But first focus on the basics, and then you think about it. Okay, but yeah, Java is not very simple. But again, if you understand the OOPS concept well and all, it's not very difficult also. But it is a huge it has a huge syllabus actually, Java. That's why people tend to avoid it. Okay, so anything else? Kuber, yes, certificate. Let the career and assignment session, like career and placement session finish. Let your deadline finish. I'll check all your submissions, assignment. I'll review them, and based on that, I would actually give like release a eligibility list. Who would be getting like participation? Who would be getting this completion certificate? And we'll actually do a virtual convocation. We'll call you all up. You join there. Okay, and the virtual convocation you would be getting like you would be it would be announced actually who would be getting this certificate, who would be getting that certificate, and in the same session your addresses would be collected for those who would be getting completion certificate, and finally after that the process would be followed to send you the certificates. Okay, this is the whole process. Any more thing, anything else you want me to want to ask me or something? Done, everyone clear? Okay then, so that's great then. Okay, thank you everyone, thank you for joining in. You people were really very interactive, and yep, I love this session entire. Like after a long time actually I'm taking session, but yes, I actually enjoyed this. So thank you everyone, take care, keep preparing, keep learning, keep rocking, and do try this dynamic programming problem to solve by your own. Also try to code it around. You can always check back. Maybe tomorrow you check the community, you would find the code for this problem. Deadline is 10th of August, Ramesh. Okay, before 10th of August you submit all the code. This particular thing is not a, whatever we discussed today, this is not assignment. Okay, just submit all those stuff what we got up to yesterday session. That's it. Check. Just not too many. It's only 3 sessions you missed, Vishal. You can check it out always. It is there in the YouTube. Okay, you can check it out. Okay, Sumit, we'll try it. I'll try to do that. Not in the next session, maybe upcoming session. I'll try to do that DSA with Java. Anindita, we used to do this, but right now we are not doing a separate DSA session. full course. DSA is like, again, like it is embedded into all other PGP courses like Python and Django, and data science, AML, web dev. All these courses have this DSA course embedded with that. Okay, Vishal, you check all the, you like check all the previous videos and put your attendance. It is open till tomorrow. It is open till tomorrow night. Okay. Yeah, Sumit, I'll try to do that. Okay, then, guys. So that's it for this data structure algorithm batch. Okay, you have one more thing in this batch, that is career session tomorrow. Don't miss it. Don't miss out. It is at 7:30 p.m. tomorrow. It would be roughly around 1 hour of session. Please attend that. That would be really great. Okay. And till then, guys, bye bye. Take care. Keep enjoying.